All right, we're on this path in this chapter to talk about all kinds of different data. Qualitative data, quantitative data, different types of data, organizing the data, whatever. Let's sort it out. All of this stuff about data. And this, in section 1.8, really categorizing data by its type. And I don't mean qualitative or quantitative. We will define these types. So define categories, identify if the categories are exclusive or not, and use Venn diagrams to organize the categories that were picked. So, all right. On page 107 in section 1.8, Mercer and Sebecki talk about this. I added a few of these. Two of them are theirs, these first two. So, well-defined categories. Let's say these. The set of all good shows on Netflix. And the second one is a set of shows with all seasons available on Netflix. Got it. So they listed these two. I have more. Fair and generous teachers in college. That's a category. All Netflix shows that have a running time longer than 47 minutes. Okay. So here are some categories that have been described. Which of these is well defined so that you can objectively determine its belongings? Okay, can we objectively determine a good show on Netflix? I don't think so. This is Aki, out. Pew. Can we objectively determine the set of shows with all seasons available on Netflix? Yes. Yes, we can. Either they are available or they are not. So this one is it's a keeper in terms of well-defined. I'm going to go ahead here. Because I'm lazy, I'm going to give these letters instead of writing them out. So I would say set B is well-defined. Can we objectively determine fair and generous teachers in college? No. You'd be surprised by how many semesters, fair and generous is in the eye of the beholder. And sometimes I've had students who are going through something in their life, and then maybe one day I made them smile. And so now all of a sudden I'm a fair and generous teacher. But maybe I was having a bad day too, and their bad day mixed with my bad day, and then they left and they were like, man, I did not like going to class today with that lady. And then now all of a sudden I'm not fair and generous just because of our moods on a particular day. But anyway, so is this objective? No. And then can we objectively determine the belongings of all Netflix shows that have a running time longer than 47 minutes? Yes. Yes, we can. So those we can objectively determine the belongings to. So I like this example from the book because, a lot of people start off with a poorly defined category and then everything kind of unravels from there. So we just really got to tighten up how we define things. Be really specific and really objective. Like, can we say yes or no that belongs to that set or not? Are those sets qualitative or quantitative? Ooh. B, the set of shows with all seasons available. So if you were going to ask the question, are all seasons of this available on Netflix? They would say yes or no. And so that's qualitative. So B is qualitative because the response to the question would be a yes or a no. And D, the question would be, does that show, is that show, this feels qualitative too. All Netflix shows that have a running time of longer than 47 minutes. Does it have a running time longer than 47 minutes? Yes or no? Ooh. D. Yes or no? Okay. Yep. Create a list of categories that can be represented using this Venn diagram. Create a list of categories. Okay, so we're going to have to pick B or D. And you know what? Let's use B and D. We have two data sets. So instead of calling them A and B, we're calling them, okay, I'm going to scrap this. Here we go. So I'm going to take this A and I'm going to relabel it with a B because that's what I labeled it up here. And then I am going to take this other one. I have a red marker. I should have labeled that with red because this is a red circle. And I'm going to label this one, instead of B, I'm going to label it with D. Okay. And then it says, create a list of the categories that can be represented using this Venn diagram. Okay, let's do it. I'm on it. First, category 1. Okay, category 1 is the set of shows with all seasons available on Netflix. So, 1. Shows with all seasons available. Okay, but it's outside of D, which means that it has a running time with running times less than 47 minutes. Okay. Less than 47 minutes. Okay, that's me being lazy. That's region 1. Region 2, we're going to go purple because red and blue make purple. Region 2, let's see. Oh, that's both. So these are shows with all seasons available, but they are longer than 47 minutes. Okay, so all seasons and run greater than 47 minutes. And then region 3. What is that? That's D. So shows that have a running time longer than 47 minutes, but it's outside of bubble B, which is the set of with all seasons. So runs longer than 47 minutes. Not all seasons. But it's not inside the red bubble, so, or the blue set, I'm sorry, or the B set, so not all of the seasons are available. And then there's a region 4 right here. Okay, so region 4, which is also labeled with this U for universal. But U is different than 4, I must say. That's confusing. Perhaps we should put this U right there for universal. Everything included there. Region 4 is, okay, that means that not all the seasons are available. So it's because it's outside of set B and it's outside of set D. So it runs less than or equal to 47 minutes. So, runs less than or equal to 47 minutes and not all seasons available. Oops. Okay, now the intersection. So here, region 2 is the intersection where they both happen. So where two sets are simultaneously happening. So, or where they meet. Intersection literally means we meet. overlap between two sets where they meet what they have in common. Oops, common. Okay, and their union is inclusive. So, oops, I like blue. So a union, or like a unity, is when it's just any region. So, okay, when it comes to here, I put this in purple because represented in the Venn diagram, that's region 2. The union is actually represented by 1, 2, and 3. It represents anything. So union unifies anything in either of these two sets. Okay, so unifies or brings together all things in any of the sets. And in this particular case, that would be 1, 2, and now I feel sad that I used green because that was the opposite of the union here, but sorry. I only have 1, 2, 3, 4, and then a very light purple doesn't show up. Anyway, okay. Intersection is where they meet or where they have in common. Union is all together. The universal set. Okay. I swear your book has a definition for this. I'm looking at right now. Because when I think about the universal set, I think about the universe. I think about being inclusive of all. But it's really more specific than that. Do they describe it? Huh. No. Oh, for Pete's sake. Okay. I thought they did, and I thought they had a better definition than the one I was thinking of in my head. Inclusive of all. Okay, and here's what I mean. So here, the universal set in this particular instance would be regions 1, 2, 3, and 4. Okay, we don't care if you were a short show where you didn't have all of your seasons available. We still want you. You're in the universal set. Okay, so you actually did have all of your seasons available, but you had short shows too. Okay, you're in the universal set. You had all of your seasons and a runtime longer than 47 minutes. You're in the universal set. And you had a runtime of longer than 47 minutes, but not all of your seasons were available. Okay, you're still in the set. So the universal set is inclusive of all as it pertains to the situation. Okay, so okay. Exclusive. Okay. Exclusive means that, so when I think about being exclusive, maybe as a couple, that means that you're together and you can't be with anyone else. And exclusive as a set means that your group is together and there's no overlap with the others. And that is similar to even when you're thinking about like VIP exclusive events. You know, like you have this, you're separated from the rest and there's no overlap. Like there's a barrier between the two. So exclusive here is this idea that there is no overlap. So between the types. In other words, there would be nothing in the intersection, nothing in common. I'm going to leave it as overlap instead of no common ground here. Because there are some positive spins on exclusive, but there can also be negative spins on that. So I'm just going to leave that. Remark. So we take some well-defined sets, and then we have this. My remark is this. If two events are exclusive and there's no overlap between them, or these two sets are exclusive and there's no overlap between them, and they don't happen at the same time, then this middle will be completely blank. I'm actually not going to write that remark down, but I'm going to write this remark down. In this last example, I made us list this 1, 2, 3, and 4. I think this list is incredibly helpful. If I ever see students struggle with Venn diagrams, it is a student who has not written this list. So I'm actually going to write that as my remark. If there's one thing that I want to drill down for this section, it is that. Write the list of all possible subsets. That's the biggest thing, in my opinion. So let's look at example 2, and we're going to do that. Okay. This information comes from 400 entrees at 75, oops, not collage, but college. It's supposed to be an E, college campuses, college campus cafeterias, thank you. This information came from page 109 of your textbook. Fat grams and calories. Oh boy. All right. So, you know what? It's totally relevant to college students. Freshman 15. So it looks like there is a set for entrees that are less than 12 grams of fat. Okay, that's cool. Those ones have less than 12 grams of fat, and these in the other bubble here have less than 350 calories. Okay. So, I am going to make the list. I don't see it as one of these questions down here, but I'm going to make this list regardless. So, none of these have numbers in them, so I'm not going to represent them as 1, 2, 3, 4. Again, I'm going to represent this as A, B, C, and D. Okay. Region A has less than 12 grams of fat, but it's outside of this bubble, so it's more than 350 calories. So this region right here in teal has less than 12 grams of fat, but more than or equal to 350 calories. Region B is in the intersection, less than 12 grams of fat and less than 350 calories. Less than 12 grams of fat, less than 350 calories. Got it. Region C is outside of this less than 12 grams of fat, so it's 12 or more grams of fat, but it's less than 350 calories. So greater than or equal to 12 grams fat, but less than 350 calories. And then region D is 12 or more grams of fat and 350 or more calories. So greater than or equal to 12 grams of fat and greater than or equal to 350 calories. This is where we get into trouble. It's delicious and terrible for us. Was a sample taken, or was the entire population included in this collection of data? Oh, well, it's 400 entrees at 75 college campus cafeterias. First of all, there's definitely more than 75 colleges with cafeterias. So immediately I know it was a sample. And then, I mean, I don't know, how many entrees are there out there? It's got to be a ton. So definitely, excuse me, I need my coffee. Definitely a sample. How can you tell? There are more than 75 campus cafeterias and more than 400 entrees. I wonder how many of you are going to be culinary people. Anyway, it's a sample. There are more than 75 colleges and more than 400 entrees out there. Is it qualitative or quantitative? Well, these are all yes/no questions. So this is qualitative data. We're categorizing them by yes/nos. It'd be interesting if we had a whole data set of how many each entree had grams of fat and how many calories each entree was too. Then it would be quantitative. But right now, nope. List all four categories being represented. Okay, C above A, B, C, and D. Okay, how many entrees had less than 12 grams of fat? Less than 12 grams of fat, A or B, and less than 350 calories. Right there. B, less than 12 grams of fat and less than 350 calories. How many? 142. 142 out of the 400. What is the probability that a cafeteria entree will have more than 350 calories? Okay, more. It said more than 350 calories. I see more than 350 calories here in these 70 entrees, and I see more than 350 calories here in this region, 140. So there are altogether, 210 entrees with more than 350 calories. So what is the probability that a cafeteria entree will have more than 350 calories? Let's see. Okay, so 70 plus 140 makes 210. And the probability then is 210 out of 400. That is 52.5%. It is 52.5% likely that you pick a random cafeteria entree and it has more than 350 calories. How many entrees had more than 350 calories and more than 12 grams of fat? Oh, that's here. These are the delicious, delectable, bad for your artery ones. Let's see. So more than 12 grams of fat and more than 350 calories. That is 140 of them. How many entrees? 140 of the 400. All right. Are these categories of the cafeteria entrees exclusive from each other? Oh, definitely not. No, it's not exclusive. They're not separated, and there's definitely overlap. Like, you can be in the category of having less than 12 grams of fat and less than 350 calories. So there is overlap between these two types of entrees. So are these categories exclusive? Nope. They definitely have common ground. You could be both. There's overlap between them. You could be both. You could. So how can you tell? An entree can be both. You can both be VIP and not so VIP simultaneously here. All right. Example 3. I'm wondering if I can get all of this in one video. Here we go. Every so often, community colleges take a survey for student activity and satisfaction. We use the CESI, we call it, Community College Survey of Student Engagement. From this, we consider some of the categories. Okay, so let's consider students who have kids, they study late at night, and they work 20 hours or more a week. That's a lot. These are what I would call, like, working super hard and working late at night type of students. Okay. Assign the top left circle, studies late at night. Okay. I have green. I have a green marker. Studies late. The top right circle, the blue one, 20 hours or more. Work more than or equal to 20 hours. Got it. And the lower circle, which is red, as kids. Taking care of some people. Should really say maybe has dependents, whatever, because sometimes a lot of my students actually take care of their parents a lot. I can't tell you how many times I have students tell me, well, I have to work because I got to help with the rent, and, you know, my mom's blah, 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 and I'm like, whoa, you are very nice. Okay. Has kids. But a lot of our students have kiddos. Use this to make a category list for all of these regions, and not to mention the fact that there's a region that isn't even shown up here. A, B, C, D, E, F, G, H, because maybe you're not one of those. Okay, like, don't pin me down according to those on none of these. Okay, so here we go. Let's list them. Okay, I'm going to use purple. Category A. Studies late, works a lot, and has kids. So, you know what? I'm going to color coordinate this because I can. So here we go. A. Studies late. Works more than 20 hours. I'm going to put works. And studies, works, and has kids. Region B. Okay, so region B is right here within blue. So it's inside the blue bubble. It's inside the green bubble, but it is outside the red set. Okay, so studies late because it's in the green, works a lot because it's in the blue, but does not have kids. Okay, so studies late, works a lot, and no kiddos. Got it. Region C. Okay, region C is inside the red bubble, so has kiddos, is inside the green bubble, so studies late, but is outside of the work bubble, no work, inside the kiddo bubble, has kids. Okay, now let's look at region D. Region D, inside the kids, inside the works a lot, and outside of studying late. So, no late study. I know this says no studying, but it's not no studying. It's just they study at a different time probably. Works a lot, 20 hours or more, and has kids. So this region D, inside the kiddo bubble, inside the blue bubble, has kiddos. Okay, region, okay, so we did A, B, C, D, E. Region E, studies late. Does not work, it's out of the blue, and does not have kids. So, no work and no kids. Region F. Okay. Does not study late. Okay, probably studies earlier. Is working more than 20 hours and has no kids. Outside of the red bubble. Outside of red, outside of green, but in the blue. And then G, region G, okay, has kids, does not study late, and does not work more than 20 hours a week. Okay, so region G is no way. There's no way I can study late. I gotta sleep. And then isn't working more than 20 hours. So even though this says no work, it's possible to work less than 20 hours. It's recommendable when you're a student, but does have kids, kiddos. And then we have a region H, which is you don't study late, you do not work more than 20 hours, and you do not have kids. Okay, I would guess that this would be describing things like risk, risk and support, I would think. Okay, got it. Every region. So use this to make a category list for every single region. Done. Fill in these numbers given for the regions of the diagram. Oh, okay. Sure. What am I going to use? I'll use this. A is 7. B is 6. C is 2. D is 3. There are 32 students in E. There are 40 students in F. There are 18 students in region G. There are 132 students altogether. Or I'm sorry, 113 students altogether. Okay, so off to the side here, I am just going to, I didn't find out what is in region H. They didn't give a number for region H. So I'm going to go ahead and add all of these students accounted for. Let's see. 32 plus 2 plus 6 plus 7 plus 18 plus 40 plus 3. Oh, that's 108 total. So 108 are in here, and 113 students were included in this data. So 113 minus 108, what is that, 5? Okay, that means there are 5 students in this region over here out of the 113 students included in this particular data. Okay, so fill them in, done. How many students have kids and work 20 hours or more each week? Okay, so it looks like we are looking at have kids and work 20 hours or more. So I'm going to look down. I'm going to look at the bubble. I like the bubble, but I'm also going to look at my list here because it shouldn't be a no kid, right? So all of those are out, but here's kids, 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 kids. Okay. And work. Okay, so hold on. So this is out because there's no kids and no work. This one's out because they're not working 20 hours or more. This one's out because there's no kids. This one's out because there's no kids. There, working kids. And up here, working kids. D and A. So I look over here and I notice working and kiddos. So if I look at the blue bubble and I look at the red bubble, that's where they overlap, where we have working kids in region A and we have working kids in region D. So sometimes the list helps me because it really, really shows me where we are here. So has kids and works 20 hours or more each week, 10 students. Okay. Out of the 113 students surveyed here. Well, surveyed for this particular part. Are there more students who work 20 hours or more or study late at night? Okay, so let's add these up. Blue region. Okay. How many are in the blue? So right off the bat, you can just look here and say, okay, here's 10, 50, 56. 6 plus 7 plus 3 plus 40 makes 56 for working 20 hours or more. And then if you want to, you could double check that here. That's region A, B, D, and F. And we got those. Study late at night. That's green. Okay, I see 32. This is 9. 9 plus 6 makes 15. 15 plus 32 makes what? 47? Okay, so 32 plus 6 plus 2 plus 7. Did I just say 57? And then, just to be sure, I just looked at the green bubble and I included all of the students within the green bubble. But here it's region A, B, C, and E. A, B, C, and E. This is very equitable though. This is pretty close, tight race between how many students work a lot and how many students study at night. 57 students study at night out of the 113 and 56 work 20 hours or more out of the 113. I gotta say, the majority of my students work, period. It is very rare for me to find a student who is not currently working, at least part-time, while they're going to ECC. But anyway, if they are not working, they are lucky. Are there more students who work this or study? Okay, so study at night. Wins the race. How many students from the survey work less than 20 hours a week? Well, if 56 work 20 hours or more, and there were 113 students included in the data, then I feel like the easiest way to answer this question is to take these 56 students out from that data. And that's 57. Oh, cool. Anyway, not that that means that they're the study late at night people. As a matter of fact, they are everyone outside of this blue. So 32, 2, 18, and 5. Because they would be, work less than 20 hours. So we wrote that as no work. C, E, G, and H. C, E, G, and H. Outside of blue. 57 of them. All right. If there are 10,000 students at ECC, about how many of them do we expect to study during the day? Okay, if you're studying during the day, then you're not studying late at night. And we had 57 students studying late at night. So, hold on. First of all, studying during the day. So we take the 113 and we deduct away the 57 to get 56 for the daytime. Then we take the 56 out of the 113 in order to get our probability or our percentage. 56 out of 113 is about 50%. Wow, that's really close. So I'm going to have to actually write that down. It is 49.6%, so just under half. And then if there are 10,000 students, so 49.6% of 10,000 is, well, I mean, I look at this and I'm like, half of that is 5,000. So this is 4,960. About how many do we expect to study during the day? First of all, this was a sample of 113 students. And so we need to realize that. So I always include this about, and because as soon as we have a sample, then there's a little bit of room for error, remember? So about 4,960 of them we expect to study during the day. All right. Example 4, our last example, is all about the movies. A senior community center offers movies each week. Of the 240 senior citizens, 75 of them watched Spies in Disguise, and 104 watched the movie 1917. What is the largest number of senior citizens that could have seen both? Okay, now I'm going to make a Venn. I'm going to go Spies in Disguise. And I'm going to go 1917. Okay, there's 240 total. What is the largest number of senior citizens that could have seen both? Well, here's the deal. 75 watched Spies in Disguise, but that doesn't say whether or not they watched 1917. And 104 watched 1917, but that doesn't say whether or not those people watched Spies in Disguise. But 75 watched this movie. So the most that can live here, I believe, in the overlap is 75. So that would be, let's see, and that means that, okay, so 104, okay, I believe this scenario would play out the largest number of senior citizens that could have seen both, because here 75 watched Spies in Disguise, check. And in total, that is 104 who watched 1917. And 75 of those actually had also seen Spies in Disguise. 29 of them had not. So I feel like the largest number of senior citizens that could have seen both is 75. Because as soon as you go higher than that, then you definitely, that person had not seen this movie, so couldn't have seen both. Of the 240 senior citizens, 75 watched Spies in Disguise, 104 watched 119. What is the smallest number of senior citizens that could have seen both? Okay, so now we're looking at, okay, I have a question. Could it be, okay, here's Spies in Disguise, here's 1917. Could it be 0? That's my first question. If that is 0, that would mean 75 people watched Spies in Disguise but did not watch 1917. And that would mean these 104 people watched 1917 but had not seen Spies in Disguise. As a grand total, that would be, I think this is going to work out. So 75 plus 104 would give a grand total of 179 senior citizens who watched movies, and that does not break how many there were possible.